share. There we go. How many had trouble with this fella here, number 14? Is that one worth doing? Jack, if you don't make your thing go away, I am going to take you off my list. It's very distracting. So, right, back to my question. Has anybody, number 14, had an issue? If you don't have an issue, I'll just move on to my next one. If you do, we'll do it. It's really your choice. You remember doing the wheel one? This thing here with the cow eating the grass? You haven't reached it, so you don't know if you're going to have trouble. Right.
Yeah, I remember doing that one. I got help with one of the math tutors.
Okay.
For it. I ended up figuring it out, but I wasn't sure that the way they, like the procedure they took to find the answer was the right one. I don't know.
Do you want me to go over it then, just to show you? I got some notes. I think it's probably worthwhile. I won't do all the details of it because that'll take too long. Maybe if I just get you the gist of how they came about with the numbers they've got.
Yeah. And you said that you have some notes on it. So, like, let's say we did end up skipping this one. Would you still post notes on this in a PDF?
Yeah, the notes to this I'll be putting online sometime on Saturday. So if you look in Canvas on Saturday, God, where am I going to put these things? I'll probably create a page called Homework Help and just find that page and click on it and you'll get a PDF of this guy. And actually, I think I've got about 8 questions that I've made up the answers to because various people have contacted me over the last few days and I've used them for why I chose the questions I chose. So right now I'm just setting this picture up. So we're told that C is 120. What else? In my version, at least, they keep changing the numbers. But A is 30, B is 60, C is 120, D is 70, and finally E is 60. And I'm just writing down all the key numbers here.
There is also a short YouTube video on this question. It's like 3 minutes long if you just look up the question. Right,
and did that help?
Major, yes, major help. It went directly through it with different numbers.
Perfect. So after I finish this one, is that typical for the questions that they have a little video, or is it just hit and miss? Sometimes yes, and most of the time no.
A lot of these questions are on the internet in some form, yes, with different numbers.
Oh, on the internet. I was thinking that you actually got it from the site themselves.
No, I searched them when I couldn't figure out how to solve the problem.
Good strategy. I'm just wondering how hard it is to find the question because the internet's really big. And were you lucky, or is there a kind of systematic way that you ask the question so that others can look at videos in the future and get that same help? I'm guessing, do you say my lab cow field question or something?
I honestly just directly copied and pasted the problem into Google.
Okay, so just take the whole question and Google it and see where it goes.
Yeah, I only had to do it with 2 of the problems, but when I did do it, I found very helpful information from reputable sources.
Perfect. I like your thinking. Right. So, well, since we set this guy up, we'll finish this one off. Takes me more time to draw the picture than it will be to do the explanation. Almost done. Okay, so here we go. And click on stop the share. Right. Are you still on the big screen for the paper? So you're seeing this big mess here. Is that about right? Okay. Now, what you've really got here is you've got 1, 2, 3, 4. Let's check them. 1, 2, 3, 4. You've basically got 4 shapes. Each one of these shapes, I'm calling 1, 2, 3, and 4. Each one of them, if you focus on them, do you notice that they're all 1/4 of a circle? So the gist to get the answer to this question is just to find out what the area of the 4 bits are and add them up. So the area is going to be made up of 1, add 2, add 3, and add 4. Now to get the area of any of those quarter circles, it's going to be 1/4 pi radius squared, right? So now the question becomes, what are the radius, or the radii, I guess, of each of those 4 guys? Now I'm going to go to number 3 first. When you look at this guy, his radius is C. That one is the easy one. Now, let's suppose that you wanted to get this guy number 4. What we know is that this entire distance from here to here, from there to there, is C. And we know this distance here to here is D. So the guy I want, its radius is C take away D. Okay. Someone is going to have...
Oh, hell. I eat ass. I'm never starving. Goddamn. I beat my meat. Turn me up. That's my jam.
I apologize. There are some people who really should stay somewhere else. If you hold on a second, I'll see what we can do about removing this person. Right. Okay, I'll make sure the next time. Next time when we do our meetings, we're going to have to use our password. Hopefully that will allow us. Okay, hopefully that will allow him not in. If you do, will you not share it with your little brother or whoever it is that this person is? And if he's not your little brother, he's certainly behaving as if he was. And we have more important things to do. So, if you wanted to find this guy's radius, won't you take the distance C again, but subtract B? And so if you wanted to get number 2, the radius would be C, subtract B. And then this little guy here, well, you know this distance here is the same as that radius, and then you take away the little bit at the side. So it's all a matter of just finding out what the radii of each of those 4 fellas are, and then doing 1/4 pi r squared and adding the whole thing up. Well, if you can imagine, I get really distracted very easily. I'm certainly distracted right now. So let's move on. Where were we? Oh, we've finished that bit. Okay. Has anybody got a question of their own now? Since, as I say, I've got other homework questions, but if you've got your own specific one, that might be more worthwhile for your time. I know your time's important.
So I have a question on section 6.3.
Okay.
And it's the last question, number 24.
Okay, let's if you hold on a second, I'll see what I can do about finding that guy. Question 2463. Okay. See what this one is? No, it's not the screen you need to see. Okay, let's try again. Is that a question you could tell me and I can write down? Otherwise, I'm going to try and see if I can eventually find it. But this is a pretty slow way of doing it. You said 6-3?
I did, yes, sir.
Well, let's see. Here we are. Okay, I found it. 24.
Yeah.
Okay. Whoops, too many. This guy here?
Yeah.
Or a version of this guy, at least.
Yeah, a version of that, yeah.
Okay, let's set this fill up. Then I can go into the main screen. We have a cosine is negative 9/13. And we're told that the tangent is less than 0. And we're basically going to find all 6 missing trig ratios, right? Okay. First things first, I need to know which quadrant theta's in. Is it 1? Is it 2? Is it the 3rd quadrant? Is it the 4th quadrant? And there's a way we can do that. It's the all sine tan cos thing. The cosine is negative in the 2nd and the 3rd quadrant because all of them are positive. Only the sine, only the tan, only the cosine are positive. So if you ain't positive, you must be negative, so that's why they're there. Now the tangent is negative. Let's see where that's negative. Well, if you look at the tangent, it's positive here and here, so that makes it negative here and here. And what that allows us to do is it identifies the only quadrant where both the cosine is negative and the tangent is negative, and that is us in quadrant 2. So that tells me that theta is in quadrant 2. Now what that will then let me do later on is find the sine of the sines, the tangents, the cotangents, so on, so on. So you might get the fraction part right. You know, it might be 9/27 or whatever it is, but you need to know is it plus or negative 9/27, for example. So far, so good. Now, if you look at the cosine, you'll find that it is the adjacent over the hypotenuse. You agreed? You remember that from SOHCAHTOA? Now, if I build a little right-angled triangle, and I make this x, I make this y, and I make this r, I can look at this situation and think of adjacent hypotenuse and so on in terms of the x and the y and the r values. So for instance, if you tell me that the cosine of theta, forget about the negative part, is 9/13, you're basically telling me that the adjacent side is 9 and that the hypotenuse is 13. So you imagine going here, you're telling me the adjacent is 9, like the x is 9, and the hypotenuse is, the hypotenuse is 13. So all we need to do now is find the guy that I'm calling y, who's also called opposite. So you can stick to adjacent hypotenuse opposite, or you can use x, y, and r. They're both totally interchangeable, right? So in this question, if I say x, this here is the angle. If I say x, you see that's the adjacent. If I say y, it's the opposite, and if I say r, it's hypotenuse. And if you look at the textbook, they kind of, I think they use x, y, z a lot. So I guess I need to find this missing fella. So if you take 13 squared, it should be 9 squared plus y squared, which is 169, is 81 plus y squared, which is, good grief. I believe I've got 88 here. Looking good. Check my working. 13, 81, 169 looks good. And so the square root of 88 is going to be the y, which is our opposite. Okay, we're pretty much ready to do the question now. Sine, cosine, tangent. I'll just do these three. You can get the other three by just taking each answer to the sine and using its reciprocal. Right, for the sine, opposite over hypotenuse. Can you hear my dog in the background? I think I'll close the door. Not sure what he wants, but he's not getting it right now. Okay, so in this case here, the opposite was the square root of 88. So it's the square root of 88 over 13. And the cosine will be 9 out of 13, and the tangent will be opposite over adjacent, which is these three. Right, now let's go back to the second quadrant. In the second quadrant, the sign, is it positive or is it negative? Second quadrant, what's the sign?
Sine is positive in the second quadrant.
And the cosine and the tangent are negative. Do you see that I've now used the piece of information we got right at the beginning to decide what the values plus or minus these three guys are? Now, if you wanted to, for instance, get the secant, then don't you keep the sign? It's still negative, but reciprocal, right? Essentially turn the fraction upside down. Now, as far as what are acceptable versions of the answer, I can't remember, was this question wanting the numbers in their exact format, which means things like -9/13, or are they wanting it like to 3 decimal places? Because the next step, it depends on what they want.
It doesn't give any particular answer. In fact, I've done a similar question, and you can do both the fraction and the decimals, and they both work. Yeah.
Okay. So it seems to be, thankfully, a little bit flexible about what format the answer is in. So the square root of 18 over 13 may well be totally okay. It's the same thing as 2 root 21 over 13, which I'm assuming is okay. And it'll be some decimal version. So if you're doing these 6 guys, it looks like you should be able to just write them down as they are. Have you tried a question, different one? Can you imagine a question where it was 3 over root 2? Does it accept that? Or do you have to maybe make sure to do it as a decimal just in case it doesn't accept that version of the answer? Anybody?
I think I've used a denominator that was, irrational or
square root in the bottom.
Yeah. I think I've used that as an answer and accepted it, but not entirely sure.
Okay. If anybody comes across that issue, if they ever did a question where the answer was 1 over root 2, and you typed it in and they didn't accept it, it would be helpful for you to tell me, and I'll warn other people if that happens. I'll just say, watch out, question 15, and be a bit more careful. But it seems right now that it's pretty flexible about decimals or exact values. And that is a great thing.
Yeah, as long as it doesn't specify, I think you can use either.
Okay, yeah, that makes sense. If it says, I want it to 2 decimal places, then you got to go the way it asks. Did that help you on that question?
Yes, a lot. Thank you.
You're welcome. Okay, that's kind of more, I feel like I'm doing a more useful job if I answer your homework questions rather than someone else's who's going to be able to see their solutions anyway, because I'll be putting the examples that you gave me earlier. If you give me homework questions early enough, I can write up solutions and put them as PDFs. It's a little bit harder to do them now. All you'll get is what's on the video, and hopefully that's enough. Have we got another question? If not, I'll just go back to my list of pre-done ones.
Can you do question 19 and 6.3?
Okay, we can do that. 6.3, number 19. I'll just go and have a look at that question, and we'll see what that ends up being. Yeah, I've seen this question before. Make sure, is this one here you're talking about? Write the first trig function, in this case tan, in terms of the second function, in this case cosine. So you're going to write tan theta equals somebody with nothing but cosines in it. So you can't have anything else like a sine and a cosine together, which would be really nice if you could in this question. And the second thing it mentions is quadrant 2. Now, it's the same reason we did the previous question. If you are in quadrant 2, what will the tangent be, positive or negative?
Negative.
Negative. So if the answer comes out as horrible mess, stick negative in front of horrible mess, right? And if it was a positive, you know, if it was theta in the first quadrant or something, you would just do horrible mess on its own, which means it's positive, right? So now we're going to look at how to take a tangent and write it in terms of a cosine. So skip by that. And one of the relationships that we expect you to know by now is that the tangent of theta is the same thing as getting the sine of theta divided by the cosine. And that's kind of halfway there, right? Now, we already figured out that it was negative, so I guess I should put that in. And if we could find a different version of sine theta that only used cosines, then we'd be done, right? That would be the end of the question. That would be the horrible mess. So let's see if I can make that happen. Well, I'm going to start with, we call them identities, with that guy. That sine squared theta plus cos squared theta equals 1. That's another thing that is a very useful thing just to know. Now, if I rearrange this by subtracting a cosine from both sides, we get that. And then, what would I need to do to both sides just to find sine then?
Square root.
Yeah. Now, technically, when you take the square root of both sides, technically, shouldn't you have a plus and a minus? I know we forget it a lot, especially with numbers, we forget it. You know, x squared is 9, and you immediately say x equals 3, and then you wonder why you got half the points. Well, it's not just 3, isn't it? Plus or minus 3, right? It's plus or minus the square root. That property is still true if you take the square root of both sides. Now, what do we know? Well, we know the answer is negative, so doesn't that mean we're using the negative version of this? So we have a negative, the square root of 1 take away cos squared, all over cosine theta. And that's the guy that they're wanting. Now, when you're in the WebAssign, there's a little, I think, from what I've seen anyway, along the bottom, there's a little palette where you can hit things like fraction button, square root button, and so on. Right, so you're happy about how you would actually get to type that into the box where the answer goes. Are we cool with that? You've managed to do it, you know, for some other question, perhaps. Okay, did I answer what you needed?
Yes, thank you.
Right, so while we're on this one, or this type of question, let me write down a bunch of things that we can expect you to use and to just know. For instance, cosecant theta is 1 over sine. secant theta is 1 over cosine, and cotangent theta is 1 over tan. We use these three identities a lot when you do those questions where it says, find all 6 missing guys. So if you know the cosine is 3/4, then the secant is 4/3, right? 1 over the cosine is reciprocal. Sine squared theta plus cos squared theta equals 1. We've seen that being used. Tangent theta is sine theta over cosine theta. And finally, cotangent theta. Now, I know cotangent theta is this fella. But he can also be written as the reciprocal of the tangent. You see the sines and cosines are swapped places. Now, these three on the right, they're going to be much more useful for the types of questions where they say, take the secant of theta and write it down in terms of sine, or write it down in terms of cosine. And you'll use a combination of this guy and this guy to do that. Are we cool? Right, where are we off to now? What's our next guy? In fact, this is going to be our last guy, because I have another meeting after this one. So what you got for me? Last chance, last question. That's scary. Is that a good sign or a bad sign? Any more questions?
I have one if
Sure.
nobody else has one.
Go for it. Which is it?
It's let's see here. It's finding the exact value of it's number 12 on 6.3.
Okay, let me just go to that one. Be quicker than you reading it probably. Where the heck are we? Oh, that's interesting. And it was question number 12? Right.
Yeah.
It says find the exact value of the cosine of, in my case, it's the cosine of -7/6 pi. Right. Although you probably get a version of that. Okay. Let's start. You might not recognize this guy, but any fraction that is in thirds, quarters, or halves, right? So anything like -7/3, -5/4, 17/3, 81st quarters, 19/6, right? Anything that has that look to it is going to be what we call a standard angle. That means you can get the answer to the trig by using your unit circle. So what I'm going to do is I'm going to take this fella, which if you had your unit circle, you'd be going that way. And that's quite a long distance. And I'm going to add 2 pi to it. And the net effect of that is to add 12/6 pi to it, which means that it is the equivalent of +5/6. Now, I don't have my unit circle on me, but can you imagine this is my unit circle? And you've got a guy over here whose the angle is 5/6 pi. This fella here has a coordinate attached to it. And isn't the cosine the x coordinate of that point? We cool? To give you a quick summary, do you know that this fella here is pi upon 6? This is pi upon 4, and there's another one up here called pi upon 3. Remember the unit circle looked like that? And this point as a coordinate, let's figure out what that is. Oops. And values like that, right? So what you'll do is you will find on your unit circle, you'll find 5, 6 pi, whatever its x coordinate is, that will be the answer. So your answer will, I can guarantee what your answer is going to be. Your answer, if it was this particular one, is going to be positive, and it's positive either a half or root 3 upon 2. It'll be one of those two, but I'll let you check that in the unit circle.
Yep, that's right.
Do you know which one it is?
Positive root 3 over 2.
Okay, so it'll be that one.
Oh, wait, yeah. Yep.
Okay, right, as I say, I have another class to go, so be careful with your information if it gets out there. We don't want interrupted as we were before. Okay, bye-bye, everyone. Have a nice day, and I'll see you sometime next week. Remember, Sunday, get everything done. That's your drop-dead date. If you haven't finished it by then, you won't be able to go back.
All right. Thank you.
Thank you.
Stay safe. Have fun.
Have a nice day.
You too.